for both AS and A2 level. Today we're going to talk about the factor theorem. I already explained the factor theorem in the previous class, but today we're going to talk more about it. We're going to explain what is the factor theorem and how we're going to use it for solving past paper questions. The previous class we talked about dividing the dividend by the divisor to get a quotient and the remainder. And we solved the cases where the remainder is 0. So when the remainder is 0, I'm going to call x plus 2 as a factor. So we proved that the divisor is a factor when we get a remainder 0 by using a long division. And the long division is a very long process. Is there a short process to get remainder 0? Is there another way to get remainder 0 and prove x plus 2 is a factor without using long division? This, the new way we call it the factor theorem. How we can prove that x plus 2 is a factor? First of all, I'm going to say x plus 2 equals 0. So x equals negative 2. And this is, we're going to call it root. Then f in negative 2 equals, we're going to substitute it in the dividend, negative 2 cubed plus 3 by negative 2 squared minus 10 by negative 2 minus 24, negative 8 plus 12 plus 20 minus 24, 0. This is the remainder, and the remainder is 0. According to that, x plus 2 is a factor. You have to be careful. This question said use the factor theorem. So you have to switch the factor to get root and then substitution. The long method will not be, the long division will not be acceptable in this question. I hope this is clear, students. Let's move to question number 2. Cube minus 20x squared plus x plus 3, where a is a constant, is denoted by bx. It's given that 3x plus 1 is a factor of bx. I'm going to underline the word factor. Find the value of a. I have two ways to solve this question. The first one by using the long division, and the second one by using the factor theorem. If you think carefully, the long division will be a very complicated method. So I prefer to use the easiest one, which is the factor theorem. 3x plus 1 equals 0. So x equals negative 1 over 3. F negative 1 over 3 equals a by negative 1 over 3 cubed minus 20 by negative 1 over 3 squared plus negative 1 over 3 plus 3 equals 0. Negative a over 27 equals negative 4 over 9. So a equals 12. So the function will be 12x cubed minus 20x squared plus x plus 3. Part double I. When a has this value, factorize completely. Excellent. Factorization, it means I have to find the quotient. In order to find the quotient, I have to use long division. 3x plus 1, 12x cubed minus 20x squared plus x plus 3. A very quick thinking, it will be 4x squared, 12x cubed plus 4x squared minus negative 24x squared plus x plus 3, negative 24x squared divided by 3x plus minus 8. x negative 24 x squared minus 8 x 9x plus 3 divided 9x divided by 3x, it will be 3 plus 3 9x plus 1 minus 0 0. By the long division, I also checked that 12 is a correct answer. According to that, 12x cubed minus 20x squared plus x plus 3 is the result of multiplying 3x plus 1 by 4x squared minus 8x plus 3. I still have 4x squared minus 8x plus 3 to find out I can factorize or I cannot factorize. But before that, I'm going to use b squared minus 4ac. Negative 8 squared minus 4 by 4 by 3, it will be 16. So I have real roots. So I can find these 3 roots by using general formula or factorization. If b squared minus 4ac less than 0, this part will not be factorized. So I don't have it. So according to that, b squared minus 4ac is more than 0. 16 is more than 0. So I have real roots. I'm going to use factorization to complete the factorizing of this function. 3x plus 1, it will be 2x minus 3 minus 1, let's check, 4x squared plus 3 negative 2x negative 6x negative 8x. So I complete the factorization for question number 2 part double. Let's move to question number 3. The polynomial x to the power 4 plus 3x cubed plus ax plus 3 is denoted by bx. It's given that bx is divisible by x squared minus x plus 1. Find the value of a. As I said, I have 2 ways, the long division way or the factor theorem way. Which one of them I'm going to use to solve part I? If I think carefully, I can't get a root from x squared minus x plus 1. This cannot be factorized. So I can't use factor theorem to get a root or a factor. According to that, I'm going to use the long division method in order to find the value of a. X to the power 4 plus 3x cubed plus 0x squared. I may use it, I may not use it. Plus ax plus 3. X squared minus x plus 1. Long division, x to the power 4 divided by x squared, it will be x squared. X to the power 4 minus x cubed minus 0, 4x cubed minus x squared plus ax plus 3. 4x cubed divided by x squared plus 4x. 4x cubed minus 4x squared plus 4x. 0, 3x squared plus a minus 4x plus 3. I'm going to divide 3x squared divided by x squared plus 3. 3x squared minus 3x plus 3 minus 0, 0, 0, because they already told me that it's divisible by x squared minus x plus 1. The meaning of divisible, it means the remainder is 0. I have to find the value of a. According to this part, I'm going to write a linear equation, a minus 4 minus negative 3 equals 0. A minus 4 plus 3 equals 0, so A equals 1. Excellent. So I found the value of A. For double I, when A has this value, find the real roots of the equation bx equals to 0. What is bx? Bx x to the power 4 plus 3x cubed plus x plus 3 is the result of multiplying x squared minus x plus 1 by x squared plus 4x plus 3. And will be equal to 0. If I look to this bracket cannot be factorized because b squared minus 4ac is less than 0. Negative 1 squared minus 4 by 1 equals negative 3. And negative 3 is less than 0. So I can't factorize it. I have no root. The root came from the second bracket. Can I factorize this? Yes, I can. So x squared minus x plus 1, x squared plus 4x plus 3, it's x plus 1 by x plus 3. So this will make the function be equal to 0, or this will make the function be equal to 0. So x plus 1 equals 0, x equals negative 1, x plus 3 equals 0, so x equals negative 3. This is factor, this is factor, this is root, and this is a root. And the question is not talking about factors, it talks about roots, the real roots. So the first root x equals negative 1 and the second root x equals negative 3. I hope today's class is clear, student. Try to solve the book exercise. See you next class. See you then.